what is Pig? Pig is an open source high-level data flow system. Now, what is that? It's an open source. Open source means it's easily extensible. So as I said, Pig is also extensible. Yes, it will be a huge challenge to open up Pig and write your own custom code. It will be easier to do it in Java or in Python using a custom code. But if anybody wants, he can go ahead, download the Pig from Apache site and tune the Apache site or tune the Pig program that he has downloaded, because it's an open source program. So Pig is definitely an open source. So you are, you do not have a product which you cannot fine tune, or nobody allows you to fine tune. It's an open source product. You can anytime download the source code from your, Apache website and start processing it. All right. And then second part is it's a high-level system. It's a high-level system because we're talking about the way in which you want to process it. So it's a high-level system. High-level means it's easy to write, easy to read. It's mostly the way you talk. It's mostly with the way you normally speak up in English. That's the way you normally write those commands. And then the third one is it's a data flow system. What is a data flow system? A data flow system is a system which on every step changes the structure and the actual value of the data. Alright, so what we mean by a data flow system is, if you consider a Java program, or if you consider a Python program, or if you consider any other program, the program will have its own syntax, the program will have its own initialization processes. Every single statements, what kind of statements you have in a programming language, guys? You normally have a declarative statement, you have loop statements, you have conditional statements, you have expressions. Any programming language is made up of all those variety of processes, right? You have all those types of syntax that constitute your programming framework. So every single programming statement will not alter the state of the data. If I am loading the data, an if statement will only do some Boolean checking on the data. It will not change the structure of the data. If I say, hey, check if age is greater than 21, that if age is greater than 21, that state is not, that statement is not changing the state of the data, right? It's only filtering the data, or it's only evaluating the state of the data. It's not changing the state of the data. So if you look into a normal programming, syntax of any procedural or structural programming language, you'll see that only 10% of the commands are actually changing the data, whereas the 90% of the commands are actually helping those 10% of the commands to change the state of the data. So if condition, for condition, loop conditions, declarative conditions like, I'm creating a data set, I'm creating a map, I'm creating a list, all those will help change the final structure of the data. But those statements themselves never change the state of the data. But when I talk about a data flow system is actually a series of commands. It is actually a series of commands which on every single state changes the state of the data. So in Pig, you will never have one single line which will do anything else apart from changing the state of the data. Or in other words, you will have a data flow like this. A gets converted to B, B gets converted to C, and C gets converted to D. So all in all, A to B, B to C, C to D, every step in that data flow system will convert your state from A, and it will change to B. From again, if you run another statement, it will change the state of the B to another state called C, and maybe C is the final state for you. C is something that you really want to save. So you do not have a lot of if-else conditions, loop conditions, or any kind of condition which do not do anything else apart from changing the state of the data. So every statement in Pig is actually changing the state of your data, which is called a data flow system. All right. So Pig is actually a tool which converts your program or commands, a series of commands, into MapReduce program. But how do you write a Pig process? Or how do you, create a Pig process? You write a Pig process using a programming language called Pig Latin. So Pig Latin is a high-level declarative language which changes which is used for writing of Pig programs. So Pig is nothing but a tool, and Pig Latin is the language using which you can write your Pig programs. All right. Why is it important? Why is Pig important? Well, companies like Yahoo, Google, Microsoft, so all big companies which are considered to be the ones which have a huge amount of data or work with huge amount of data, all of them use Pig for any kind of analytics, log processing, web crawling, or any of these data processes. So all huge amount of data processes can be handled using Pig, and some form of ad hoc processing and analytics can be done in Pig. So Another advantage, guys, one of the advantages, what Pig provides, which a MapReduce doesn't provide, would be ad hoc processing. So what do you mean by ad hoc processing? So normally, when you guys become data scientists or data engineers, you guys will be working very closely with business guys, right? You'll be working very closely with business analysts or business based users or top level managers who are looking into the businesses. So normally how it goes on, the discussions will be, you guys will be going into conference rooms, talking about certain business processes and finding out how, or what kind of analytics can be done for changing or making a business decision. So normally, a lot of time you'll be going and talking to the business clients, brainstorming a lot of sessions and finding out how you can add a lot of value to the business. In those cases, what happens is, you want to start a discussion by putting out a lot of numbers in front of the group, and then start your discussion by or based on based on those numbers. So ad hoc processing is plays a very big role in those brainstorming sessions. You go and sit with your clients or with your business partners, with your business clients, and then they'll say, hey, let's see one thing. Let's try to find out what is my sales volume that have changed for every week starting from last quarter. So from last quarter, I want to find out every week how has my sales been working out. Now, you cannot go and talk to your business clients and say, hey, I would write a MapReduce program. I'll implement the program. I'll test it, and then I'll push this jar file that I'll create into my program, and then maybe after 1 week I'll come back and give you a result. You cannot do that. Because Java is a very process-oriented, or Python is a very process-oriented programming paradigm, right? You cannot just, say, hey, I won't need my time, and I'll write the code and I'll give it back to you. So you cannot just have the entire, cycle which helps you process the data, right? So your programming cycle cannot be large. Ad hoc querying means somebody comes and says, I need those reports, and you say, hey, you know what? I might not be able to create an entire report based on terabytes of data, but I'll give you a very good data sampling report. I can sample the data and give you a small report, and based on that report, we can start having a more discussion on this forum. And that's what you do, that's what you normally try to do it using Pig. So in Pig, what happens is you go and talk to the clients. The clients will want to start a discussion based on certain processes, and you go and talk to them, and then they'll say, hey, I need this and this, and it'll be very easy for you. You write some queries, just a couple of commands, right in front of them. You do not even have to understand things. You just run those commands, because these commands are very simple. You run those commands, get a sampling data chart, show those data charts to people, and then they'll start understanding how the business is changing, and then they can start the discussions on that. So a lot of times, the discussions are totally based out of the ways in which you want to do ad hoc processing. And ad hoc processing can be done only with high-level languages like Pig. So Pig gives you the flexibility to do all those ad hoc processing and data processing. Hadoop engineers and Hadoop developers are same or both different roles. They are totally different roles. Alright, so use cases where Pig is used, well, I would say everywhere. So web logs, data processing for search platforms, ad hoc querying, or quick prototyping. These are the typical use cases mostly that you'll be using. Quick prototyping is more about, you do not need a full-fledged solution. You do not want to see how your program runs on 1 petabyte of data. 1 petabyte of data is not your end goal. It can be your end goal, but it's not the exact need of the hour right now. So what happens is, your business clients will say, hey, you know what, let's create a quick prototype. Maybe 10 minutes, we'll prepare a prototype, we'll see the sales volume, we'll compare the sales volume with maybe already published sale volume of other competitors, and we can see how we are moving. Or we can categorize our products and see how each product is performing. Quick prototype. I do not want all the data, but maybe I can do a quick prototyping only with 10 different data from 10 different categories. Your company will have hundreds of products from, or maybe you'll have thousands of products from hundreds of categories, but you want to pick up a couple of products, from 2 or 3 different categories and see how things move on. So all those quick prototyping, where your response is important, your discussions are important. For all those quick prototyping, Pig would be the absolute perfect solution providing tool for you. And then the ad hoc querying, where you go, somebody says, hey, I want a solution right now. And then you say, hey, and I can provide you a solution, but you are not You're not stressing out on the actual, the stability of the solution. You're not saying that, hey, this solution can work with terabytes or petabytes of data. You're just saying, hey, I can write a very small, quick prototype query. That query can give us some data, and I can start having my business discussions on those data. All right. So for those kind of decision-making query-based processes, your ad hoc querying, quick prototyping will give you a lot of advantage and a lot of flexibility, which actual programming in MapReduce might not give you in custom-written MapReduce framework. All right. And apart from that, it can solve all those traditional cases. Like we're talking about web logs, data processing, all those can be solved using Pig. So only as I've been saying, guys, when you get a business-driven use case, when you find a business-driven use case, then your first choice of attack would always be Pig. You see whether Pig can provide a solution for you or not. If Pig can provide a solution, then yes, Pig is the way to go. Otherwise, you have to think about a separate solution. But on top of that, this is like the classical cases. But apart from the classical cases, support for ad hoc querying and quick prototyping are the two more reasons why Pig is quite favorable with all those Hadoop engineers and data analysts and business analysts, right? So Pig is a very, very common and very sought after tool set for all these guys because of these features, like quick prototyping and ad hoc querying, which others are not providing. All right, guys, how you can use Pig to solve the problem? Okay, so let's brainstorm and see how we can solve the problem. So what we'll do is let's talk about a use case. So this is a very simple use case. This use case talks about two different tables. One is a visit table, one is a pages table. And imagine that this is a simple company database. The company is a good company, and company is keeping a track of which users are visiting which pages. All right, and internally they have a page rank associated with each and every page. Okay, so can you use Pig to analyze Twitter feeds? Yes and no, because this is what I've been talking about, guys, since class 1, that Hadoop framework, vanilla framework, doesn't give you real-time processing capabilities. It doesn't give you real-time processing capabilities, right? So, point is, if somebody is downloading these Twitter feeds using certain different ways and dumping it into HDFS, then yes, Pig can be used for analyzing those. But if you're talking about, if you're talking about streaming data, if you're talking about all those real-time data, then Hadoop cannot help you in this, unless and until you're talking about real-time processing engines, right? But if the data comes to, if your data comes to Hadoop, HDFS, then that data, that Twitter stream is very similar to your log files, right? What is the difference between a Twitter and a log file? There is nothing, right? All of them are unstructured or semi-structured data. So if I can process a log file, why cannot I process a Twitter feed? So this is a simple use case where the company is keeping track of the visits that employees are making into different pages throughout the day. Let's say they're tracking which page, who is going and visiting which page. Every page has a page rank. So I hope guys you know about page rank, right? You guys know about page rank. And page rank, guys, is actually a very classical case of implementing big data. A huge big database solution would be to find out page ranks. So like what a word count is to normal Java and Python is page rank to a Hadoop-based world. So page rank, normally you start doing a page rank based algorithm for a particular domain. Let's say BBC. For a BBC, those guys will be doing a page rank, and they'll find out which pages would be ranked first. So if I search something in BBC, what should I get? Which pages should be higher up in the SEO? And Google takes it one step forward, and they do a page ranking on the domains. All right. So a lot of different things. Same Amazon, right? So if you go into the Amazon and you want to do you want to search certain things. You search for computers or laptops. So which pages? There will be hundreds of pages. Which page will be showed first? That will be based on the page rank, right? So page rank gives the relative page ranking or rating to all the pages in the same domain. So something like that. So normally you also have page rank associated with each and every domain also. So that's what Google does internally. Now the use case here is very simple. So the company is keeping track of which employees are going and visiting which pages. And now what I really want to do is I want to find out on an average. So guys, here think about it and hear me out. That's what you guys need to provide me a solution with, right? So my problem statement is The company wants to find out, on an average, if the users are visiting good pages or bad pages. How do you find out the bad page? The bad page would be that most of the time I'm actually seeing pages or URLs which are having less than 0.5 page rank. So my responsibility is to find out those employees in my company who on an average throughout the day has been visiting bad pages. Nothing to do with Hadoop, guys. If you know and if you understand how to build your logic, you can just tell me how do you provide a solution to that. If you know SQL, guys, you can provide a SQL based simple overview to me. High level language overview is okay with me. Alright? So if somebody says I do this and this and I'll get it, that's absolutely spot on with me. So I want all of you to think about the use case solution and come back and provide a solution to me, saying how do you solve this kind of a use case. Alright? So we're not talking about Pig right now, we are only talking about a very simple use case that you can help solve. Maybe with SQL, maybe with any other high level language, or maybe just overall a pseudo logic. All is okay with me. But I want you to give me a logical solution for a use case that I've just described. Create a database of all the web pages searched. I have two pages, visits and pages. Users are visiting certain pages. If you look into the data, it will be very easy for me to understand how they're related. I want to find out if people want, if on an average throughout the day, people are visiting good pages or bad pages. Alright, so this is the user and page data set I have for day one. Let's say for this day one, I want to find out if people have been going into good pages or bad pages on an average, right? So I want to find out the report of those employees who are going into bad pages. I mean, the SQL will also follow those steps. If you are thinking about what kind of SQL you are building, your SQL will actually be having the steps. All right. Step one: if you get compare, compare, not really. Join both tables by URL. Spot on. Yes. I have to join both the tables based on URL. That is spot on. Yes. If I want to analyze the data, I have to join the two tables. I'm going to join the tables based on my foreign key, which is URL in here. All right. So I have got my data now, where I'll have both these tables together. Right. So for every table, I'll have what is the page rank of the URL. Right. So something like 0.9, 0.9, graph is 0.2, 0.7, Flickr 0.9, and 0.9, something like that. Okay. Step one, join tables. Step two, what should be step two? Once we have the data now, our business use case says for every employee. So I have to group the data based on employee. So employee here is user. So I have to group the entire data set based on my user. So all of you guys, you can find out where you guys are going wrong, right? So this is spot on, right? First was join, second was group by. If I'm creating group by, I'm going to get two groups. One for AMI and one for Fed. Fed will have only one data, but that's it. It doesn't matter. We'll still have two groups. Two groups of data. Now what, guys? Third step. Get average page rank. Average page rank. Alright. Count the number of pages. Nothing to do with count the number of pages. We have the page rank itself. So all I have to do is to find out the average. What is the average of the group? An average of the group. So I need to get two average. AMI's average and Fred's average. That's the reason I have grouped it, right? So average of AMI and average of Fred. What is the average? Average is 0.9 plus 0.9 plus 0.7 divided by 3. So average, right? So average is a very common term. So I can find out the average page rank of this group and average page rank of the group. So step 3 was average page rank. Alright, perfect. After average page rank, guys, what is my fourth step? What will be my fourth step, guys? Filter. Yes, filter. Filter based on what, guys? Filter based on rank? No. Filter based on the average, right? So I have to find out if the average page rank is greater than some value, which is set by my company. Okay, so Vairam says 0.5. Yeah, 0.5, 0.6, that is whatever my company has said. If my company says 0.5, all my employees on an average should be viewing good pages, and I'm going to tag good pages as 0.6. That means this guy has been going into more good pages than bad pages. And then if I'm talking about somebody else, then it can be good pages versus bad pages for that person. So fifth one would be find out or filter out those employees who have been visiting bad pages, which is nothing but average greater than or less than, or average less than, let's say 0.5 or 0.6, whatever my company said. So if I get those list of users, then I can go back to them and say, hey, please explain why during the entire day you have been surfing bad pages compared to good pages. So maybe he has been visiting a lot of social media websites, and I can easily track it, right? So this is how you normally build a logic, guys. So all of you who has helped me in this, great, guys. That's the way you should be thinking about providing a solution, a business-driven solution into a technical solution. All of you who have also attempted it, but have not come close, so you guys have now known how do you build those, right? So that is one important aspect, guys. The questions will come as business problems. You have to convert them into technical, logical, use cases, right? So first thing was load the data. So, imagining we're talking about a Hadoop-based solution now. So load the data from HDFS, load to data sets or load to folders, and then join based on URL. Once you join it, group by the users. When you group by the users, you compute the average page rank, and then you filter it out by 0.5. So once you do these 1, 2, 3, 4, 5, once I write 5-step process, I can easily provide a solution. What's my problem statement? Find the users who are visiting bad pages. What's the output? A report of 5 on all those employees who have been visiting bad pages. So just by writing or converting my business problem into a series of definitive problem executions, I've been able to provide a business solution, a report which helps them in ensuring employee productivity. All right. Now moving ahead, guys, the important thing is that's exactly the way Pig also works. So Pig is a data flow program. Right? We talked about data flow process, data flow programs. So this is exactly a solution of a data flow. Here, if you look into every single step, step 1 to step 5, every step is changing the dynamics of the data. So what I'm trying to do here is I'm joining two folders, and I'm creating a third folder which is holding up the data. So my data structure has changed from 2 tables of 3 and 2 columns each. I've got 1 table of 4 columns. Second thing is this is now normal text of data. Group by users have changed the data dynamics by converting the entire series of rows into 2 groups. Compute average page rank. So I've introduced another third column which is average now. So I'm changing the data continuously. Every single statement changes the dynamics of the data. There is no single command which is doing anything else apart from changing the data. So that is what a database or that is what a data-driven programming language or a tool set is. It always changes the data structure. It always changes the internal structures and nuances of the data. So you cannot, we do not have those commands. We do not have a list of commands that do not do anything on the data but assist other commands. So we do not have those kind of commands. Here, every single command changes the dynamics of the data. Same with data. So once you do that, it is easier to write those kind of programs because it's so much simpler to comprehend what each command is doing. So here, every command works only on the data and nothing else. It doesn't do anything else apart from changing the actual structure of the data. Now, this is what a pig does, and that is how we will be writing the pig. So every time you given a problem statement in your mind, or if you want in your notebook, you always convert that business problem into logical subsections. And when you've been able to convert your logical problem into subsections, every subsection can be converted into a pig command. So we'll see how to convert each and every process into a command. Right. So every single data flow can be converted into commands. All right. So how Yahoo uses Pig? So just a simple problem statement. What Yahoo does with their own data. So Yahoo has a lot of pipelines. So I'm sure, guys, all of you have at some point of time have worked with Yahoo pipelines, right? Yahoo pipeline was one of the Yahoo utilities that worked really well for a Yahoo. So what they did was you can create pipelines, and one of the end of the pipeline can be attached to a REST-based service or any kind of APIs, and the other end of the pipeline can be put into any kind of data repository. So pipelines were really, really good from Yahoo, where they can actually go ahead and get data from all those different services, web logs, event logs, database logs, and all those. You create a pipeline, and Yahoo does the rest for you. So Yahoo built a lot of log pipelines, and when you have the data, which is log data, unstructured data, when you have the data coming from a lot of different sources, you want to do a lot of ETL. ETL is like cleaning the data, changing the structure of the data, massaging the data, or removing certain entities or characteristics of the data. You want to do a lot of ETL process. Well, Pig was absolutely spot on, great tool for doing all those stuff. So people, in Yahoo was actually using Pig for a lot of ETL-based custom processes written in Pig. And then the researchers really wanted to use some kind of a tool to quickly test their prototype theory. They had a theory saying that, hey, I want to find out. I think that when I data, and if I go and check this pattern of my log data, I can find out if one of those web servers is actually getting a lot more hits than others. So maybe my theory is the load balancing is not working correctly. So what I want to do is I want to do a quick prototyping and see the number of hits based on the hours that goes into every single maybe node. So using a quick research prototype based on the log files, I can go ahead and test out my theory, seeing whether actually my load balancer is doing a correct job of redirecting the loads into all appropriate channels, or it is actually putting more load into one of the nodes where the other is actually relatively free. So whenever I have a lot of these theories, I can easily do a research on my theory. I can easily make a prototype on my theory based on a tool like Pig, which is having nothing to work with in terms of programming background. I do not want to do a lot of program-hungry, resource-hungry processes. I'm only specified, or I'm mostly concerned about testing my theory instead of the actual programming paradigm of it, right? And then Pig integration with streaming makes it easy for researchers. All right, so this is a great example where what actually happens is, guys, normally when you go into web programming, so what is your actual source of data? Our actual source of data in a lot of different actual use cases are actual scrapping of the data. A lot of people do a lot of web scrapping. So while you're doing a lot of web scrapping, the web scrap can be pushed as input to your Pig job. So Pig actually can handle web scrapping data. So what kind of program you normally write for web scrapping is Perl scripts. So Perl is actually the de facto scripting and scrapping language for the websites. So if you have a Perl-based utility written which scraps the data, that web scrapping data can directly go into your Pig script, and you can schedule it, let's say, every day. So every day you can scrap a lot of data and push it into your system. Let's say, you are creating or you are building up a comparison website. I want to find out the comparison of, of the same, let's say, mobile phone in 3 different sites. So you can scrap the data from 3 different sites and push the data into your Pig script. The Pig script can now process the data and create a wonderful scripting table, which can show you what is the change of the data, or how these prices are different in 3 different websites. So if you want, it can do that for you. So it says, as far as pipelines are concerned, how do you determine whether to use Flume or Pig for streaming data, which includes transformation? No, Flume is used for data ingestion, guys. That's what I've been saying. Flume is a data ingestion tool. Pig is not a data ingestion tool. Pig is a data analytics tool. Yahoo had different pipelines created. Right now, they do not have, but it's just an example how Yahoo uses Pig. This is not about how you should be using Pig. The slide talks about how Yahoo has been using Pig. So Yahoo has created these pipelines. Now, right now, pipelines are not existing in Yahoo. They have put down all this because it didn't make a lot of profit. Point was, Yahoo used pipelines to, get all those server details. As far as you are concerned, if your client has data, you need to bring the data into HDFS, then you should be using Flume or you should be using other processes. But Yahoo used, all those pipelines for ingesting the data. The question is, here we are not focusing on what tools they are using for ingesting the data. The point is, whatever tool you choose, when the data comes to your HDFS, either using pipeline or using Flume or using Hadoop APIs, when the data is in HDFS, you can use Pig for doing ETL. That's what you should take out from this slide, right? And Pig streaming is not streaming data, guys. It is your own Perl script. It only works with Perl script, where the Perl script output, the scrapped output, can be fed into your Pig instead of pushing it into HDFS first. So Perl script can push your scrap data in memory into your Pig script. has that capabilities. So here we're totally talking about ETL based processes. So if you have a lot of ETL driven use cases, like your data is coming from multiple channels, you want to cleanse it, process it, manage it, then instead of going forward with expensive ETL tools which might or might not work with big data, you can definitely use Pig, because Pig is built out for doing the exact same thing. Alright, now we have been learning and talking a lot about Pig. Second part is, how do you write Pig? What are the ways of implementing Pig? And how do you write some code in Pig? Alright, so now we are focusing on the implementation part of it. Now, Pig can be executed or implemented in 3 different ways. Alright, so one is embedded mode. Embedded mode means Pig actually can be called from inside your Java program or inside your Python program. So if you have a Python program or a Java program, you can invoke Pig directly from inside the code. Chances are you'll never do it, because if a person is already working with Java or Python, chances are he'll be mostly using MapReduce. He'll not be doing a lot of cross-technology processes. But yes, it is possible that if you have a Java program, from internal of Java program, you can call a Pig script or a Pig program. Alright, so this is step 1, or one way of implementing Pig. Second way is script. What is a script? Like a SQL script, you can write a .pig script. You can create a .pig script. The .pig script can contain a list of commands. So you bundle a list of commands, a list of handwritten commands, into a special file called Pig, and then you can schedule or execute that .pig program. Alright, so that .pig can be executed just like that. And the third one is grunt shell. Like you have a SQL plus shell, right? Most of the tools does have a CLI based tool or CLI based shell. Similarly, you have a shell for Pig, and that shell is called grunt shell. So normally in dev environment or quick prototyping or testing out, what you'll do is you'll fire up a grunt shell. Inside the grunt shell, you'll test out all your Pig based commands. Once you're very confident about Pig commands, you can go ahead and convert those series of commands into a script. Alright, so you have a grunt and a script based way of implementing Pig normally. Pig is a data analytics tool, and it can also be used for ETL type process. Is that correct? Yes. Yes. So actually, analytics is not different from ETL. ETL is a process type. Analytics is a bigger umbrella. So if you say that I want to do in ETL, the transformation part is also a part of analytics actually. So yeah, I mean, ETL is a very specialized technique, whereas analytics is a very big term, right? So both of them actually mean some way it boils down to the same point. But yeah, Pig can do both. Which technique we are generally using, script or grunt? Both. Grunt is your SQL plus, like a SQL plus CLI mode. Now nobody is going to give you a CLI command based tool to go and run it in production, right? Nobody is going to say, hey, you log into production, go to the CLI prompt and then type in your commands. In production, you're not going to use grunt. So in a development box, when you start doing grunt, after you are sure about everything you have processed, you bring all those scripts and you package it using a .pig script, and then you push the script into production. In production, you execute script, not the grunt. But both of them gives you a flexibility of Pig commands. Alright, so either in grunt or in Pig, the command is not changing. Your Pig command remains the same. Grunt is a CLI interactive mode. Script is like a .SQL program which can be executed directly. So this is how you execute a Pig program. Question is, what are the different modes in which Pig runs? We have seen it in Hadoop. Hadoop has different modes, right? Guys, can anybody recollect what are the different modes of installing Hadoop? Cluster, pseudo, yes. So we normally have a cluster which is a distributed mode. We have a standalone mode and we have a pseudo mode. Yes, 3 modes, right? Hadoop can be installed in 3 modes. Similarly, Pig can be executed in 2 modes. One is a MapReduce mode. A MapReduce mode is nothing but your actual distributed parallel processing mode, which talks about a MapReduce or an HDFS mode. So you normally use Pig, or else you can just do a local mode. Local mode means your data can be, Pig is a specialized case, guys. It actually was, it is actually available in Apache as we talked about. What is the advantage? Advantage is you can install Pig in your Windows laptop also, and your Pig program can take input from your C drive and process it in memory, and can be stored into C drive again. So those mode where your data is in a local system and you execute the data just in memory, it's called a local mode. You're not distributing it, you're not parallelly processing it, you just, it actually acts as a standalone mode where for your testing purposes, you can pick the data from a C drive, run some commands on that data and store the output into another folder. Pig can run on that mode also, right? So it can run on a local mode or it can run on an actual distributed MapReduce mode. Okay, so these are the only two ways. But as I said, in an actual productionized cluster, there is only one mode, which is the Pig actual HDFS mode. There is nothing called local mode in production. Local mode is mostly associated with your own, idea of unit testing and debugging and implementation. All right. So Pig is made up of two components. One is Pig Latin. So Pig Latin is nothing but your actual queries, your commands, which is expressed as implementation strategies, which gets converted into data flows, which eventually becomes your MapReduce program. So every single data flow command that you write eventually will turn into a MapReduce program. And then it has an execution environment. An environment which works on top of a data storage platform. So it can work on Hadoop-based cluster. When you work on a Hadoop-based cluster, you work on a MapReduce mode of Pig, it becomes the actual productionized version of Pig. But you can also work with a local single JVM as a standalone mode where your data on your C drive or in a local file system and you process it further, right? Both of these can be easily executed. So both of them together is you implement both of them together and it becomes your entire Pig engine, right? So your Pig has a programming perspective, which is Pig Latin, and also has an execution environment, which is more of a Hadoop cluster. Now, Pig execution, that's what I've been talking about, that, the best thing, why Pig is so, famous, why Pig is so, acceptable, why Pig is so much sought after as a developer's tool is because you do not need a specialized Hadoop cluster where you have to go and set up your Pig. Your Pig can be executed or your Pig can be installed in your local computer, even on a Windows computer also. And then you can test out your Pig, your commands can be tested out, everything can be done, and then you can push it into cluster. So your testing environment, your actual implementation, your unit testing, everything can be done on your local Windows machine without even having a Hadoop cluster or without even really thinking about distributed programming. You can just type in, check out the syntax, run your queries, and once everything is done, then you can think about moving or pushing your program into cluster. Now, we talked about the Pig Latin program. So Pig Latin program is the program used for writing Pig jobs. And so what is that Pig Latin program? So Pig Latin is actually a series of data flow commands. So when you write a Pig command, it will be the Pig Latin command. And when you write a Pig Latin command, that Pig Latin command gets converted into a MapReduce program. So if I have a MapReduce program, if you look into the other one, guys, if you think about it, this one. Here, if I'm saying that I have 5 commands, if I say that I have 5 commands, so in Pig, I'll convert each of the 5 commands into a data flow statement, and each data flow statement is nothing but a MapReduce program. So it is a collection of MapReduce program. Okay. So if I have a script, the script has 4 commands. 4 commands will get converted into 4 individual MapReduce programs. So all of this MapReduce program will be executed one by one for solving a business problem for me. All right. So that is exactly what we mean by from a data flow Pig Latin program, right? So a collection of commands transform into a MapReduce series of MapReduce jobs. So if I write 5 or 10 different lines of commands in Pig, it is not that it gets converted into one single big MapReduce program. No, it gets converted into 10 different distinct individual MapReduce processes. All right. Now we're going to go about implementation strategies and architecture of Pig. Not so much into architecture though, but yes, most about the implementation strategies and syntax. Can we see the internal MapReduce program which is generated by Pig? Unfortunately, no. You can see it for Scoop, but Pig doesn't give you that flexibility where you can see that program. So no, with Pig we cannot see that program. Are there any logs generated? Yes, logs will be generated by Pig, and the logs will be the same logs locations which is actually our MapReduce location. So it will be on your history server. And when you run the program will also provide the output or logs. You can put a log in the console also. So logs can be dumped into the console, or it will be available in your job history server. All right. So Normally in Pig, when you talk about Pig, Pig has 4 distinct data types. Pig has 4 distinct data types. Lavanya says history server. So yarn logs goes into log history server. Shafiq says, I'm going to write some Pig scripts. Yes, we're going to write Pig scripts. So Pig has atoms, tuples, bag and map. What is an atom? Atom is actually nothing but your smallest set of primitive data types. So all your primitive data types are collected under atoms. You talk about integers, doubles, long, boolean, all of them are categorized under atoms. So atom are nothing but primitive data type. Tuple, what is a tuple? Tuple is an ordered list of continuous data. It's an ordered set of data. So the closest you can think about tuple would be a row of data in a table. So one single row of data can be termed as tuple. Tuple is implemented like this: A, B, C, D, or whatever. So this is a tuple. It's an ordered set of data. So A, B, C are different atoms or any other data types, and an ordered set of data would be called as everything in Pig is actually built from tuples. So it's not array. So what is the difference between, so guys, now with this, arrays of same data type, spot on. Guys, array, it's a universal data type. Any programming language you have gone through, array concept remains the same. Array is always about a single data type. You cannot have arrays of different data types. But here we're talking about tuple. It's an ordered set of data. We are not specified about the type of data here. A can be an integer, B can be a boolean, C can be anything else. So we are having an ordered set of data like we have for a single row of data in a table, right? A single row, you can have an employee ID, employee name, phone number, true, false, flag, anything. So it's an ordered set of data. Okay. Now, what is a bag? Bag is a collection of tuples. So the closest you can think about bag would be a table. So it's an ordered set of data or ordered set of tuples. So a series of tuples. So tuple 1, 2, and 3. 3 tuples together can be converted into a bag. So bag is nothing but a collection of tuples. Alright? And then the fourth one is map. What is a map? Map is a specialized data type that has a key value pair. So it has a key, it has a value. The key is always a string data type. The value can be anything else. It can be as complex as another map, or it can be as simple as an atom. Alright? So atoms are normal data type, a primitive data type. Tuples are ordered set of data. Bag is a collection of tuple, and map is a data structure that contains key value pairs. Alright, so these are the only 4 kinds of data type, or only 4 kinds of data that we have in our Pig tool. So these are nothing new. Actually, the terminologies will be new, but atoms, tuples, and bags, these are actually the data types that are available in almost all programming language, right? So the terminology is a little bit different, but otherwise it's all the same. What is this data type? What is T? So this is actually a tuple. Now let's go and check out what this tuple contains. What does this tuple contain? What is 1 here? Atom. So it contains an atom. Then you have something called like this, which is nothing but bag. And you have this, a key value pair, so it is a map. Now this is a bag. Bag of what? Bag of tuple. So it is a tuple of atoms. And it's a map of what? Right? So this is a tuple. The tuple contains 3 elements. The first element itself is an atom. The second element is a bag. The third element is a map. The second element, which is a bag, itself is a collection of 3 tuples that are tuple of atoms. And the map that you have, it is a key value pair that is a map of atoms again. Right? So the point is, tuples or maps or bag can get as complicated as you want. So you can create any complex data structure using a combination of all these 4. Alright? What is T? T is the data. T is the name given to this data object, right? So every data, is implemented, or every expression that you write is a variable. So T is a variable, which is a tuple, right? So T represents a tuple data type. Like you say integer I, or like in SQL program you say name is a varchar. So T is a data type which is of type tuple. Now this is the exhaustive list of data types we have. So we have bag, so you can represent bag as normal bag, tuple as tuple, map as map, integer as integer, long as long, float as float, double as double, string as character array, and byte array as byte array. Only one question from this side, guys. How do you represent a string in custom Java MapReduce? How do you represent it, guys? How do you represent a string in custom written Java MapReduce? It is text. So a text in MapReduce is a string in actual Java, is a character array in Pig. Alright? So the remaining things also change. So that just to give you a actual understanding and brief, and that's what we are talking about, right? So string is same thing as a character array in Pig, is the same thing as text in classic custom MapReduce. Default data type. Is there anything called a default data type in any programming language? There is nothing called a default data type. There is nothing called default data type. Data type has to be specific. What about date data type that we have in Pig? In normal programming background, in any program, guys, in any program, honestly, in any program, what does the timestamp signify? It is actually long data, 0117. It signifies in GMT the number of milliseconds that has passed since the midnight of 1900, 31st January, or 1st January, 1900. You pick up any language in the world, the timestamp signifies the number of milliseconds elapsed after the midnight, which is the 1st of Jan 1900 in GMT. Nude says it is 1970. I don't think it is 1970. I think it's 1900. But again, I can check it out for you. But I think it's 1900, guys. Okay, so this is a standard concept of date time in any program, guys. It is always in milliseconds. Even if you convert, if you have a high-level language like Java or .NET, when you convert something into date, internally it represents the same way. It represents data in the same way. It's always long data type. Okay, so in Pig also you represent the data in a long data type. Even in Unix. In Unix there is a specialized date time. It's called an epoch date time. EPOC. ECPOC. Yeah, I mean, you don't have to know about this, Kunal. That's okay. I'm just talking about how do you implement, what do you signify? I mean, you can just Google it out. Nothing to do with Java, or Hadoop. I was just explaining that date time in any programming language is always implemented or specified as milliseconds, which is in long, and that represents the number of milliseconds elapsed after the midnight of 1900. That's what exactly I was saying. But that's a universal concept. Time in milliseconds, you can just Google it. They'll give you the history of how they maintain this time series. All right, nothing to do with Hadoop. Just giving you a heads up about how things are. All right, so let's go and talk about something very specific. We now know how to write a Pig program. I mean, we do not know how to write a Pig program, but we know what are the building blocks of the Pig programs, right? We know what are the data types of the Pig program. Now, Pig will have very specialized command-based functions, which will help us do repeatable jobs. So she says, do you have built-in functions in Pig to convert timestamp into DDM and YY? We do not have it. If you want, you can write an UDF for it. But universally, everybody uses long data type actually. The log files, everybody normally uses long data type. But yes, you can write an UDF for that. So we are going to go through a series of functions, guys. And these functions are the built-in repeatable functions. You can use the function as many number of times as you want, and when you convert your business problem into a series of steps, each step will be using each of these or one of these functions or operators, right? These are not exhaustive list of operators. We are not talking about the exhaustive list of operators right now, but these are the most commonly used operators, right? We have a lot of other operators apart from that. In every version of Pig brings along with itself a series of new commands. Having said that, the operators are these operators are very standard operators, and you can use these operators to implement your business-driven use cases. All right, so we have categorized this use cases, or you've categorized this list of commands into 5 sections. First one is loading and storing. So first thing you ever do in a program is to load the data from HDFS, right? So you have to load the data from HDFS and start processing it. Now, let's talk about it. So the first command would be load command. Load command is used to load the data from HDFS into your Pig program and then process it. Store command. Store command is used to save the output or to dump the output into your console. All right. So load is used for loading the data from HDFS. Store is used to dump the data or to output the data into console. And dump is used to output the data back into another output folder of HDFS. All right. How do you load the data into a custom written MapReduce? What is that API guys use for loading the data? Come on guys, we spent three classes on MapReduce. Inside the MapReduce program, to specify the input. Yes, but what was it? What we normally use? What is that generalized word we normally use, guys, to associate the input? Sankatan says text input format. Yes, default is always text input format, guys, and by default it is the input format. Input format specifies how do you read the data into your mappers and the reducers. So your load of data, HDFS data that you load into your mappers always comes through input format. So load is nothing but your input format that specifies from where in your HDFS you're loading the data into that program. Dump is same as output format. Your output format specifies where in your HDFS the output created by the end of the program will reside, and dump does the same thing for you. What we do not have in custom written MapReduce is a store program, and that is what Pig brings into the table. We're talking about ad hoc querying. We're talking about quick prototyping. So that's what you normally do using store. Store is used for outputting your sample output into your console. So the output of a MapReduce program that you write using Pig can be written back into your console. In the console, you can see how things are, and you can test out your program by using store command. So load, store, dump used for interacting with your HDFS. Filtering the data. How do you filter the data? Yes, it saves a relation to the file system. So what is the file system, guys? HDFS. Yes, so that's what we were talking about, right? Okay, so the second thing is filter. So if you want to filter the data, you load the data from your HDFS and want to filter the data, you can use filter. Distinct is used for removing duplicate rows from the data. For each generate, from each generate is a command used for moving through each and every tuple of a bag. So if you have a bag and you want to loop through each and every tuple of the bag, you normally use for each generate command. And then you have a stream command. Stream can be used for loading the data from a Perl script. So your Perl script, when it scraps the data, the scrap data can be pushed into a Pig job using a stream command, right? So it can only learn and understand the Perl script, which is an external program. So Perl should run as an external program, and the output can be pushed into your Pig. Now, grouping and joining. So if you want to join data sets, use join. If you want to co-group data sets, use co-group. If you want to group the data sets, use group. And if you want to cross the data sets, use cross. The actual idea behind each of these commands are equally same across all commands that you are facing, right? So these command doesn't have additional specific meaning. These are the same meanings that we have. A join will always do the same function no matter what we are talking about it, right? So a join in Pig is equal to the join in SQL. The output should be very synonymous. Sorting is used for sorting. For sorting, you can use order or limit. For combining two data sets, you can use split or union. Union is just like adding up 1 plus 1 is 1 and 1. Split is like if you have 1, 1, 1, you can split it into two data sets, like 1, 1, and 1. All right. So these commands are very simple, generic commands. How to use them in Pig? We're going to check it out later. Shafiq says, does Pig support all kind of joins? Not really. But you can create all those kinds of joins by a combination of all those commands. You can create all those commands. You can have a combination of those commands, and you can create a different set of joins. Normally, it is always equi-join, right? So Pig normally supports equi-join. All right. So guys, one question from my side. Now that you know about all those, all of us know about these commands, right? So these are very generic commands. Pig doesn't have a specialized meaning for the command. What is the difference between a join and a co-group? Group from similar data? No. Co-group and group are no way related to each other, guys. Join and co-group are related to each other. So there is no similarity for co-group and group. We are talking about join and co-group. All right. I'll just give a very quick overview, guys, but you guys have to go through these. Okay. If you have any confusion about these commands, you have to go through them, guys. These are very generic commands. All right. So if I have an employee data set and a department data set, employee is 101, employee name is E1, and it has a D1 department, and D1 is associated with, let's say, analytics. If you join the datasets, you'll have 101, employee, D1, and analytics. So you join two datasets, you get a third dataset. The third dataset will be an independent dataset. There is no way you can find out what is the origin of the data. There is no way you can find out that this dataset, which was the actual A and which was table B. It loses the originality of the data. The third table that you create doesn't have the originality of the data. It loses its own originality. In co-group, when you join two datasets, you have to join using foreign key, of course, but when you join it, you get something like this. So even if you have one single record in the third table, the data would be divided based on the originality of the data. So you still understand that the first part of the data comes from table 1 and the second part comes from table 2. Sometimes it's important in a lot of business use case that you have to find out the originality of the data. Your originality of the data has to be kept intact, and that is what you need, and that is the difference between co-group and. So I have EMP1, 101, D1, and D1 analytics. So if I do join, I'll be getting dataset like this. That's my dataset. But if I do co-group, I'll be getting dataset like this. So that's the difference between co-group and group. And all of you are asking the difference between co-group and group. Well, there is no dissimilarity or similarity between these two, because co-group and group are nowhere related, guys. Nothing to relate these two. Join and co-group are related. Okay, that's group. Sorry, that's join. That's co-group. That's how the output will look like. So here you are keeping the individuality of the data intact, right? So your individuality of the data, the origin of the data is kept intact. And trust me, that is, there are a lot of use cases where you need that. All right. Thing is, what does null signify? Now we all agree, guys. We all agree that when you talk about a big database solution providing tools like Pig or any other tools or techniques, the biggest challenge is the data that we fetch will always not be absolutely spot on. We cannot guarantee the trustworthiness of the data. We cannot guarantee the correctness of the data, because the data is being collected from different angles and different sources. If the data was in a relational database, we knew that data always followed schema on write, and we are always confident the data that will be available in our RDBMS will always have clear, absolute, flawless data. But here, because we are talking about data being collected and 90% of the data being collected from all different sources, there is no guarantee of the actual correctness of the data. And because the data comes from different angles, there can be a lot of senses where the data can be empty, null, blank, not available, and all those stuff. When we try to do analytics using Pig or using MapReduce for that sake, our biggest challenge is we know that the data set will have corrupt data or unclear data or not well-defined structured data or data which, although correct, but a lot of different places the data is not, actual values are not available, null, right? And our program, we cannot just keep on throwing errors. So guys, what will happen if I say, in a typical case, if I say select sum of salary from employee table, salary is a column that holds a double data type, and one of the data is null. For some reason, null crept into one of the rows in the table for salary, and now if I do a select sum of salary from the salary table in sequence, it will throw out an error. It will say that I'm trying to do an arithmetic operation on one of the columns that has non-numeric value. I'm sure, guys, you might have faced the same error message a lot of times in your career, right? That is a known error, and this error is, is absolutely correct, because that's how the table should be designed. Our table should be designed ensuring that I cannot have a non-numeric data going into a salary value. If somebody has designed a table like this, he had done a terrible mistake. But in a Hadoop-based world, I cannot, enforce this kind of dependencies. I cannot enforce this kind of challenges, because my data sources are totally varied. Data sources are always pretty scattered, and most important thing is, we're talking about, data set of terabytes. One single, incorrect row cannot jeopardize my entire data analytics. My analytics cannot be jeopardized because there are some anomalies in the data, right? So in these kind of use cases, in tools like Pig, nulls are treated as unknown values. They treat it as unknown, that at this point of time I do not know what the data is. So if you're trying to do a select sum, or if you're doing average or anything, even though it is null, they're okay with that. even though it's null, they'll still ensure that the entire process is done and that row will be skipped. That's it. So do you get the difference between null in RDBMS versus null in big data, guys? That's what people, that's how internal structure is. So she says in other data storage, double cannot have null as string. So null doesn't mean NULL, guys. Null is not even a string, right? In Hadoop-based world, null is, in an RDBMS world, null is not a string. Null is a special, data type. Null is a data type in any RDBMS. I'm not talking about putting null as quotes. Null is a data type in any RDBMS, right? But if you have a null value, you cannot sum it up. But not so in RDBMS, not so in HDFS. If you're having a null value, you can still run all your operations in there. Shashi says null data type is ignored in the sum function in Oracle. I'm not sure about Oracle. In MySQL, it doesn't get ignored. All right, but Oracle, are you sure? And I'm not sure about that, Shashi. To be very honest, I've not tested it in Oracle myself, but I doubt a null data type is ignored in the sum function. I doubt it. Shashi says yes, it is ignored. Okay, so if you have tested, then I'll agree with you. But I can at least tell you from MySQL perspective. All right. So once he says null is ignored in Oracle, then Oracle is getting smarter than day by day. All right. So in big data world, null is a specialized value. It means unknown, and it will not impact your actual analytics process in any ways. All right. Now. Normally, with any data type we have, when you load the data from an HDFS world, what we normally do, guys, is when you load the data from HDFS, what you do is you do some schema. You create a schema on the data. Do you agree, guys? That's what we talk about. We had a lengthy discussion the other day, and we said that's what you mean by schema on read. When you're reading the data, you have a schema in your head. Even if you do it in a MapReduce, guys, in MapReduce also you do the same thing, right? You take the data, you tokenize the data. When you tokenize the data based on comma, you are at some point of time in your head, you are actually converting the data into an actual schema, right? So knowingly or unknowingly, it becomes a schema-oriented data then. From unstructured data, you're getting a schema out of it because in your head, developer, you have created a schema. In Pig also, you have to define a schema. The schema can be defined using different ways. One is binary storage. The binary storage is a storage where you can use it for loading all those binary data. So if you're talking about non-UTF-8 data, ASCII data, ASCII data, so all this can be loaded using BinStorage. Same with Hadoop, same with custom MapReduce. You do not have a BinStorage process created for Pig. Pig doesn't provide this, but Apache has come up with a different package. I think they have a package now with the sample BinStorage. You can go and download the BinStorage if you want from Apache side, but it doesn't come bundled with Hadoop. There's a Git repository which maintains this BinStorage. PigStorage is a universal one. It loads the data using the delimiter that we provide. So you can specify what kind of delimiter you provide: a comma delimiter, a hash delimiter, a tab delimiter, any kind of delimiter. You can create the data, or you can tokenize the data by that delimiter once you load the data from HDFS. TextLoader is the one which is delimited by new line character, so you can read the entire line delimited by /n, new line character. CSVLoader, loading CSV data, and XMLLoader, loading XML data. So these are the kind of loaders available in Pig. You can use any of these loaders and you can process structured, unstructured, or semi-structured data. Right? So XMLLoader can be used for loading XML data or JSON data. CSVLoader can be used for loading all comma separated values. TextLoader can be used for loading the entire data as a single string. PigStorage can be used for loading the data which are delimited using a special delimiter. And BinStorage can be used for loading all non-UTF-based data. So this is these are the kind of operations and loaders available in use which can ensure that you can read any kind of data using Pig. Guys, what is the what is the similar analogy that we have in custom MapReduce, guys? What do you call those specialized APIs which is used for reading specialized data? What is that called, guys? What is the class called? Alright, so now we're going to go ahead and run some programs. Why do we have a name of a tool like this as Pig? Nothing to do with the actual Hadoop based architectures and all. It's a very funny question, guys. It's just a brain teaser. Why people have named it as Pig? Alright, they could have given it any kind of name, but why Pig? So why Pig is a question that I put forward in, and once we come back from the break, we're going to try to see what kind of rationale they have given for anybody who has given the name Pig to a tool like this. Like actual pigs who almost eat anything, the Pig programming language is designed to handle any kind of data, hence the name. So yeah, absolutely spot on. So one of the reasons why they have come up with a name like Pig is all about, we're talking about structured, unstructured, and semi-structured data, and Pig can handle almost any data, right? It can handle any kind of data, and that's the reason the name is Pig. So if you are into big data, guys, now that you are, if you go and check out the O'Reilly books will always have a cover with an animal picture in that, and these animal pictures are very relevant to the kind of processes that things can do. So if you think about it, Hadoop, you resemble Hadoop, which is an elephant, and it's a sharp memory. It can do a lot of hard work and huge, so it is tremendously huge. So the biggest living creature on the land, right? So every single animal representation of Hadoop actually makes a lot of sense. So Pig also is the same. So how do you go into Pig? So as we said, you just type in Pig. If I say Pig and nothing after that, I'll go into a distributed mode of Pig. And inside the distributed mode, I'll go into a grunt shell. So this is my Pig grunt shell. All right. So this is the grunt shell that I'm talking about. So if I want to exit from here, I'm going to exit the data from here. Quit. Exit for this for Hadoop. Now, if I go and check out my data in Hadoop, I'll just say Hadoop fs minus ls word counter. So I'll not have word counter. Pronounce this Hadoop designer's kid had toy elephant that was designed in Hadoop, and his kid used to call it Hadoop. Not really. Hadoop is actually one of the characters in one of those children's animation book. There's an elephant whose name is Hadoop, right? So it's not that his kid gave the name. The name of Hadoop, the elephant, was pretty popular with kids' book, and he gave it the name. But again, it was significant of the amount of data, workload it can do, and the memory it has. But again, these are this how true is these statements, in the sense that did a person name it Hadoop and then backtrack it to something, or did the person give it a name of Pig and backtrack it that it can eat anything? These are the questions of a debate, guys. I'm just saying this for fun. Somebody says you can always have a answer given back to that. Mukesh says why Pig? Yes, so why Pig is because okay, so I got it. Some fun topics that can help you just to start up a conversation. All right, I'll update this data or upload the data into Hadoop. I'll just say Hadoop fs minus put employee.txt into sample input, and I'll delete the output. I do not have to delete it. I can do away with that. Okay, so I'll go to the Pig run shell. Suppose my responsibility is to filter out all those data that has department D1. All right, all the data that has department D1. If I have to do first thing that my use case is pretty simple. Get the data and find out all the employees, create a report of all the employees who are in department D1. So what is the first thing I need to do? Load data. Spot on, guys. Yes, I need to load the data. So I'll say A equals to, A is the variable name. We have just seen, right? We have talked about it. T is equal to the tuple. So A is nothing but the name of the variable of the record that I'm giving. I can name it anything I want. It's just a variable name. I'll say load data. So we have seen the common command names. I'll say load what? HDFS data. HDFS data would be sample input and something star.txt, or whatever you feel like. It takes Wi-Fi characters to show you. Load the data. Now, when we load the data, we have to give a delimiter specification. So we'll say using PigStorage. So we have talked about PigStorage, comma, right? So load the data using this PigStorage. So I'm specifying the delimiter as schema on read. What is a schema? So if you remember what was that, guys, I totally forgot that. Okay, so this is employee ID, EMP ID, ename is of type string. How do you specify string in Pig, guys? We've talked about it. How do you specify string in Pavanis as character array? Yes. And then you have department again as character array. So I have loaded this data using a comma separated delimiter, and I have been able to create a schema on read so that A as a tuple contains employee ID, employee name, and department as ordered set of data. All right. So this is how I have the data. Now when I have the data, I can say B is equal to see how we are doing every step as a data transformation step. Every step is changing the characteristics of the data, right? So we'll say filter. So second step is always filter, right? So first is loading and filter. I'm going to filter the data based on department. So filter A by what? What we need? We need department. Department is equals to D1. All right. So now A and B are done. So If I want to display the content of B, guys, so I have loaded the data and I have filtered the data based on B. Now, whatever data I have on B is my actual filtered output data. That is the report that I want to create. So I'll say dump B is nothing but display the output in my console. And once I run this dump B, it gets converted and it will start running a MapReduce job. So let's see the MapReduce job. Alright, so if you see that, it started a job, it says job something.jar. It has internally converted into a jar file and started processing it. Alright, so we'll have all those internal, processes created, the MapReduce job created for us. We only have to, ensure that the output is, shown back to us. Pretty simple, Pig is very simple, and the syntax is a little bit different from SQL, but being a high-level declarative language, it's so simple and easy to pick it up. So as a process, guys, so if you look into this, that's what we have, right? So 101 and 103, these are the two employees who work with department D1. Now, if you want, how do you want to store the data? So instead of, dump, you only have to say store, right? Store B into, we have seen that command, right? Store command into your HDFS path, store B into sample. While running the filter command, backend converts to MapReduce, right? So not only the filter command, every single one of them, right? Every single one of them. But internally, the MapReduce program will not start unless and until you either write a store or a dump. When you fire a store or a dump, then only it will backtrack and convert those queries into actual, MapReduce program. Unless and until you request for an output, these commands will be stored into the grunt shell. It will not, execute it. So this is lazy loading or lazy execution. So Pig works with lazy execution. It will not execute any program actually unless and until you are requesting or demanding it for an answer. Is Pig a part of the Edureka VM? Yes, it is a part of the VM. Yes, if you only have 100 columns and I want to read only the third and 97th column, is it possible specifying column position? Yes, why not? See, if you are asking me like that, it is highly possible. So what I have to do is, if you think logically, guys, that's what you do. If you ask me, I would have loaded the entire data as TextLoader, and then using the next command would be to tokenize the data, like we did for Java, right? In Java also, from here also, we can tokenize the data using our own custom delimiter, and we say, hey, divide with the comma, and then it gets converted into an array. Now, once it gets converted into array, you can take the third element and the 10th element from every tuple. You can do that. One way is, you write all 97 elements here. You can write all 97 elements here, which will be a clumsy way. You write all 97 elements here, and then you choose which element you want. When you say, only select employee ID and department, you can also do that. Or you do not use PigStorage, you use the text storage, and you load the data as normal text string, and convert everything into normal, normal text data, and then tokenize it in your program. If there was a case to dump 2 times, how to put? You can dump anytime you want, right? See, I can dump anything, guys. I do not have to specifically say, how to do it. Let me give you an example. So A is this one, all right? So I can dump A. So because you are doing dumping the data for every variable, so you can just say dump A. It will be dumping A. Later on, if you create another variable called B, you dump B. So nobody is restricting you from dumping one time or n number of times. You dump every single variable as and when you want, right? Variable you have created, you can dump that variable. Make sense? Is it like system out? Yeah, it is sort of like system out. It is showing the data. Dump command is putting the data into the console, the output in the console. So it is easy and simple, in certain ways. Because you are just testing out your program. That's the way you test out your program mostly. You can dump A, you can dump B, whatever you want. Alright, now coming back. So if you have 2 data sets, so you load the data, so you say A is equal to load student data, B is equal to load, let's say, employee data. So you can have n number of load statements. Each statement should be loading data once. What will be the life cycle of the variables? The life cycle of the variable will be for the session. Till the time the session is open, you will have the variables available to you. When you exit from it, you're going to kill all those variables. Now, dataset A can be loaded from using a load statement and loaded into A. Dataset B can be loaded from another HDFS folder and loaded as B. And if you are doing a group by, you can just say group A by name. Output will be exactly the same as you expect in a SQL environment. You're grouping A by name, so name and the data. MapReduce program will be very, very specific to a programming language. Can you use if-else condition to check any condition based on that load the data? No. As I said, it is a declarative language. You do not have if-else condition, guys. You load the data and you filter it, right? So if you so what I can do is if you think logically, guys, you can get the answer yourself. So if I have a large data set A, I filter the data based on two conditions. So from A to B, A to B based on department 101 and A to C based on department 103. So I'll have from A, I can create two data sets B and C based on a filter condition. Internally, it becomes a if condition, guys, to think logically, right? Now, Shashi says how to create a script. Creating a script is very easy. You just say vi sample.pig and then you just say A is equals to load sample input star.txt using storage as, what was that? Employee ID, right? ID is integer, key name is car array, DID, department ID. So see, guys, that's the beauty of schema on read, because I do not have a hard-coded schema set up. My schema is associated with my program. I can give it DID name or I can give it department ID name. I can just give it any name I feel like. Okay, so I'll just close it. I have sample.pig. How do I run it? I'll just say pig. It's going to execute internally and give me an output or store the output back into HDFS. If I had used dump, had I used store, it would have stored the data. Because I'm using dump, it's going to print the data. Is there a way to validate the SQL in Pig? Well, this is not SQL, right? No, so there is no validation as such. Similar to your, are you talking about the syntax highlighting and all? There can be some ideas available. Normally what you do is you type a command and just press enter and see whether it's, because if let's say I give a wrong statement, right? So I go into the Grunt shell and I give a wrong command. It will tell me that the command is right or wrong. It will tell me that, okay, instead of, let's say, char array, you just say string. It will tell me that there is nothing called string. Okay, so it is, intelligent in certain ways. So what I'm trying to say, guys, is very important that I want all of you to go ahead and write at least or run at least one command from the entire set of Pig commands, right? Try out a filter, a distinct, a for each, a join, a go group. So I want you to go ahead and try at least once and let me know how it works, because this is very simple. The syntax is super simple and easy. All of you can and should be able to do that. Should not be a challenge. The reason I'm saying this is because unlike Java or anything else, you do not need the programming expertise on that. Is the variable A or B has any limit in case if we have a huge data set? No, there is no limit as such, guys. There is no limit. Because if you think about it, even in the MapReduce, when you convert something, everything is variable based, right? So everything is associated with the variable, right? So there is no limit like that. Always remember that the data processing is happening. The data processing is happening based on the blocks of data. Can you reuse the variables? Yes. What I'm trying to say is, guys, using these series of data, using this series of programs, it will be very easy for you to tokenize, group, count, and do a word count. And let me know how many lines it took for you to process the data. Okay. So let me see, how you guys can, what is the minimum number of lines you can use for, writing a word count. So, just give it a try. Try out these commands, and I'm sure it will be very, very exciting, guys. Unlike MapReduce and all, or Java and all, you do not need all those, programming background. It is very standardized, and it's always command-based. So it will be super simple and super fun to work with Pig. And I want all of you to go ahead and have good hands-on in Pig. Also, if I need to put some condition on data processing, how can I do that? So if you want some condition, that's what I've been talking about. I don't see a reason why using these commands you cannot put a condition, guys. I think these are sufficient enough to put any kind of conditions. So I want you to try all these commands and see if you can make sense of it. And if you think logically, I think every single use case can be converted into a series of these operators. I do not see a use case that requires an explicit if or else. Right? I think everything can be covered up using this set of operators. Okay? Give it a try. Think about a use case, and I'm sure, can we check how many records are processed by one Pig command? Yeah, why not? See, when you convert something like when you do a load statement, the load statement will convert itself into a bag, right? So when you say A is equal to something, on the A, you can find out how many records A has. So there is a command for that, you can try it out, but you can find out the total number of records A has. Alright, so it is easy and simple. You can do that. Because when you say A is equal to something, it has converted all lines of data as a bag, right? So it is a bag of tuples. Every tuple represents a record in the HDFS data set. If you find out how many number of A's are available, you can do that. I mean, how many records are there in the A, you can do that. Point here is, it will be a very bad idea to do a word count, or line count on A. That's not what you use MapReduce for, right? Because if you want to do, okay guys, a simple question. If I want to do how many number of lines are available in a data set, how many number of reducers will run in the program? How many number of reducers will run if I want to find out the number of records in A? The number of records in A. How many reducers will run if I convert that into a MapReduce program? The number of reducers that will run if I want to find out the number of lines in the entire data set will be only one. Cannot have 3 reducers running or 10 reducers running. I need to have only one reducer. If I'm running one single reducer, then does it become a parallel processing or does it become sequential processing? Now everybody has to go into one single reducer. So if the number of reducers that in my actual business process goes into, it means I'm not even leveraging Hadoop for parallel processing. And in that case, I doubt if MapReduce would have been the correct choice or if the business use case was actually good enough. So wherever number of reducers turn into 1, it is the worst possible business case that I could have thought about. Whereas if I'm having the number of reducers to 0, that is the best possible use case I have converted my business case to. So that's how you think about. So any use case you think about, always think from a perspective of whether it is actually going and making itself as a MapReduce program. Alright, so I want all of you guys to go ahead and practice these Pig commands. Super easy, and it's very, very intuitive. Once you start running a command and you see the output, you feel like doing more and more. So go ahead and try it out